Bonjour, Mark. Probably, okay, there you go. Scott, VK4CZ and Kevin, VK4 Uniform Hotel.
Yep.
Both of you from Redcliffe?
Yep, we both Redcliffe.
Yep. And
Both Brisbane VHF as well.
yep, absolutely mad keen microwave guys. Ralph and I have both been up there with them while Scott here anyway, while we've been doing some of the MAD days, microwave activation days, and this is some of the gear they use. So anyway, much appreciate them coming down today and having a bit of a talk about it and explaining a lot of the details, like setting up the frequencies, the problems, the getting the heights, the altitude. Anyway, over to Scott.
Thanks, Mark. Thanks, everyone. And as Mark said, I'll do a bit more of an introduction. Get out of the way of that. Otherwise, the guys who are streaming may not see it properly. As Mark said, today is really about just giving a really basic introduction to microwaving and give you a sense of what is capable and what can be done, and more importantly, some of the activity that actually is occurring in southeast Queensland, because I know a lot of people, particularly down here on the coast, don't get to see what is happening up around Brisbane and give you a sense of some of that activity. One of the things we'd love to do once we finish today is probably dispel a couple of the myths that exist around microwaving. A few little bullet points I put at the top there. First one is microwaving is exclusive. It's these weird people who hang around on top of hills. Probably partly true. It's unachievable. Hopefully and later on, when you come down and ask questions, we'll show you some of the gear. It's actually incredibly achievable. It's a fortune. It does if you really want to spend the money, but you can do it really cheaply as well. And last one is only for the technically elite. And when we do the introduction, we'll prove that's actually not the case, because neither of us are engineers. And I think one of the other misconceptions is everyone who's on microwaves is an engineer. So we'll do that. So lastly, they are accessible. They're available to you to use as a licensed amateur if you are a standard and a full call. It is actually reasonably priced to enter. You can get in very cheaply, and why I bought this little panel set up down the front here, which we'll talk to a bit later. And it actually isn't that hard. Righto, a quick introduction. I'm Scott, I'm VK4CZ. I've been licensed 36, nearly 37 years. I was 2 when I got my licence, I was 16. I've been in microwaving since 2014, so it hasn't been a long time for me. A little bit earlier with 1296, but truly on microwaves I started in 2014. As I said, I'm not an engineer, I'm actually a corporate strategist. I currently work as a chief of staff for one of the insurance groups. So I do not have a technical background, it's all self-taught. From a home station perspective, I am fortunate. Kevin and I both live in the northwest of Brisbane, out in acreage area, so I do run a pretty competitive both HF contest station, but also through to microwave, with capabilities from 160 through to 3.4 gigs. I can run EME and have high power permits, so I can run on 6 metres and 144 on high power, and 432 I've got the capability. I don't have elevation at the moment, but I have completed contacts on 3 bands off the moon, using ground wave and the moon. I do the moon rise or moon set. From a portable perspective, I also can run from 80 metres right through to 10 gigahertz. And then lastly, Best DX, which we'll touch on a bit later, and when we get to the end, there's actually some pictures and also some videos of some of the contacts that we have made. Microwaving traditionally, and I know when we're out in hilltops, people a lot of the time actually ask you what you're doing, and you explain that we're running microwaves, commercially maybe a short range, 15, 20 kilometres. What we typically like to do is try and push the barriers and push that out as far as we can. We don't want 100% reliable signal, we just want to make that contact. So from that perspective, my Best DX, 1.2 gigs is ZL1RU, from 2.4 is ZL1 TPH portable, and on 3.4 gigs it's ZL1 TPH portable as well. Kevin, do you want to jump up and introduce yourself?
Yes, I'm Kevin. I've been licensed a little bit longer. I'm actually in my 50th year of being licensed. I'm actually a medical practitioner too. I have no technical background. I'm entirely self-taught for radio. But I've been a ham longer than I've been a doctor. And I've just packed up being a doctor because I've retired, but I'm still a ham and will be for as long as the ticket keeps going. I've been interested in microwaves for well, since 1971, so that tells you how long, and things have changed enormously. If anything, it's got much easier to do. It's now well within the capability and the price range, as Scott has said, of just about everybody, really. There are special aspects to doing microwave stuff, but I'm just not a one-trick pony. I'm interested in HF as well. I'm interested in building, and I'm interested in meteor scatter on VHF. So those are the things that I do. I actually hold a number of the national and state records on some of the microwave bands, and to have something to push against, to just push things out, get further and further range, even if you can only do it now and again. That's what pushes my boat out, and I'm quite happy to go out and fail. In fact, I think if you go out and try some really long microwave parts and you don't fail often, then you're not pushing hard enough. What is it they say? If you're falling forward, if you fall on your face, you're still moving forwards. Yeah. That's it for me. I'll let Scott complete his talk. I'll talk about some of the practical stuff, some of the things that we brought with you to show you, and I'll talk you through some of those later on.
Right. Thanks, Kevin. Righto, 9 little things we'll cover off today. As I said, this is really an introductory, give you a sense of what is capable. We'll touch on what are the microwaves, really just look at what the frequencies are. We'll work our way through some of the modes that is used for operating, some of the propagation, and we'll talk to some of the different propagation modes that we can actually, probably the best word is exploit rather than activate or utilise. Quickly getting started, a little bit of what is the basics around getting started and getting up on some of the microwave bands, and we'll give you some examples of how to do that. A little bit of a focus on a couple of the bands and talk to those specifically, probably the lower frequencies. Then last part, we'll touch on a little bit around where you'll find some of the activity around southeast Queensland. And then lastly, as I said, there's some pictures, but importantly some videos to give you a sense of actually what can be achieved as well. So let's get going. Before we start, just to give us a little bit of a sense of who's around in the room and your experiences, quickly, what's the highest band you operate? And what's your best QRB or distance? Anyone?
2 metres is my highest. I used to be able to talk simplex from my home, which is on the hill over there, on FM to a mate of mine who's in Canungra, but he's actually in the valley. Yep. And I thought that was pretty reasonable given the terrain. So yeah, that's probably my best.
So about 40, 50 k's max,
maybe
not even
that.
Like
that, yeah.
Yep. Anyone else?
I can sunshine case from 2 metres. From
2 metres. So a bit under, probably 80 k's line of sight. Yeah. Okay, hopefully we'll expand that and give you a little bit a better view of actually what's possible, but you know, you're not trying hard, as Kevin said. Well, let's push it a little bit harder. Okay, what are the microwaves? What I grabbed was a little visual that gives you a sense of where they fit within the actual spectrum. Mind you, there are some Australians now playing down in the terahertz space. Actually, the designer of the 122 gig system that I've got in the corner, he's now playing in terahertz, but effectively they are just radio waves, they're just small. When you do look at it, and that's one of the things I did before coming here, is actually to say, is there actually a really precise definition of microwaves? There are 1,000 different definitions out there. So the easiest way to look at it is anything really that is from 1 gig or 1,000 megahertz up. So for us as amateurs, that's our 23 centimetre band. But best of all, microwaves are a hell of a lot of fun, if you like a little bit of a challenge. And one of the things that probably asked a lot, and when you consider it that I operate right from 160 metres right through to 10 gigs, why do I do microwaves? It's much the same as I do most of the bands, but for microwaves, for me, it's about the challenge. The biggest thing, and I think Kevin helped spur this on probably about 10 or so years ago when you moved into the neighbourhood, the home brewing access side of actually microwaving was to actually develop the interest back into what I had as originally as when I first got my licence as a 16-year-old of building things. I'd actually lost that, I completely became a black box operator. Microwaving really opened the window back up to being able to home brew again and actually pushing myself, because again I'm not qualified, to push my own learning, to actually create some equipment, but then being actually able to take it out in the field and test it, which is actually fantastic. The experimenting, for me, when you say you can't do something, for me that's the instant I can have a go at it and try it. It's both professionally but also personally. I'm competitive, so when you say that's not possible, let's try and make it possible. It is seen as the new frontier. I think based on the last little conversation, most of you guys are probably 70 centimetres may be the actual limit of what you're currently doing. Yeah, there is so much more to amateur radio once you get beyond that. In fact, the whole spectrum above that is about 400 times bigger than the available spectrum from 70 centimetres down. So for the available space, it's significant. Probably won't touch on all these. Touch on the availability, it's there. We actually have access to it, both as a standard license, we'll touch on in a sec, but also as advanced. We can actually access these bands, so again, it's the old use it or lose it. One of the nice parts is the low noise, which is fantastic when we are trying to work those really weak signal contacts and really push some of the boundaries. One of the other nice parts is the antenna gain available. And we'll talk to some of that a little bit later, but you know, when you're using a normal 5-element Yagi, say on 20 metres, fortunate enough to have one of those at home, it's 10 or 12 dBi from memory. Yeah, we're playing with it's about 30 dB right up at some of these much higher in the actual gain. So it gives us the opportunity to actually get enormous amounts of gain from the antenna systems. Lastly, if you have started to play with some of the VHF, UHF field days, the moment you get on the microwaves, the points that you actually attract for your contracts exponentially are greater the higher you go in frequency. So the moment you start adding some of these bands, your total score, and again being competitive, gets higher. And lastly, it is addictive. I started with the total view of I was only going to do one microwave band. I now have 7 or 6. So it's one of those things where, from my perspective, I started with 1, very quickly to 2, and it's just multiplied. So from that perspective, really great. Within the Australian environment, we have access to 23 centimetres through to 4 millimetres, and there are 3 actual higher bands that we also have available. Most people will probably be aware of up to 3 centimetres, which is 10 gigahertz. We actually start to expand down here. And 122 gigahertz, I've just brought down my new 122 gigahertz transverters to have a look at. It's not complete yet. It has been turned on, but it haven't had a contact with it yet. So as I said earlier, there's a huge amount of spectrum, a huge amount of space available to us that we can actually access. And importantly, if you are a foundation, it gives that little bit of an impetus to upgrade, but if you're a standard, you do get access to it. You've got access to 23, 2.4 and then 5 as a standard. And I think one of the misconceptions is standards don't get access to microwaves, so they actually can. Righto, the modes. Microwaves are just radio. We're operating the same modes you're operating on HF and VHF. We have access to SSB and CW. Still probably the most common when we're out on top of the hilltops. SSB is probably 90% of the contacts we're actually making. A little bit of CW, not too much. Probably more so when we're working the tropo to ZL. The openings we get across to ZL, we're probably starting it on CW, progressing to SSB. Although in the last year or two, we're starting to actually see the opening of the bands. We're starting on the digital modes, progressing to CW, then progressing up to SSB. There is a little bit of FM, not much. Stefan, VK4CZ from Brisbane, loves his FM. Whenever we're working Stefan, he always gets us to QSY to FM. So there is a little bit. And there are some parts of the spectrum still used for amateur TV, both slow scan but also digital. So again, what you're doing currently on either HF or VHF, you can do on microwaves as well. Too far. Just touching on the different modes of propagation, there's actually quite a few that are available to us, and each one is different, and we'll talk to each one. I think the most common one is line of sight, and it's the one most people associate with microwaves. It's that point-to-point, uninterrupted, without any of the geography getting in the way. Ralph's experienced a few of them in microwave activity days. We are trying to get to the highest points, and then somebody else a distant location doing that. What we can expect on most of the microwave bands, even 10 gigs and above, is up to 200 kilometres on those contacts, and they're usually fairly easy to achieve. It's not that hard on line of sight to achieve that. It's unaffected by solar. We're purely just worried about the atmosphere. There are a little bit of conditions that the humidity plays a part in, and particularly when we get to the higher frequencies, at 10 gigs and above, we actually start to see actually the high humidity impacting the actual propagation. What we do, and this is an example from a couple of weeks ago from the Microwave Activity Day. Kevin was based up at Mount Moblin, up in the Bunya Mountains. I went down to Green Hills in Boona, and this was the path profile we did before we went out. So one of the key things we do, sometimes we don't, but probably more often than not, is we look at the path profile. For this one, we actually understood we could have a small challenge. The line of sight path is the green line through the middle. We knew there was going to be a potential impact on that path. We actually were able to complete on that path right through to 10 gigahertz, even with that interference or the dirt in the centre of the path. So again, it was possible for us to actually still complete that, and with some really amazing signals. Again, Ralph saw that one. Kevin on that path, that was put down bottom, 171 kilometres. On 10 gigahertz, Kevin was 40 over S9. And again, we'll show you some videos just of those signals that we actually can achieve. Mind you, if I had been down here somewhere, it would have been 0. The next one, and this is the one that really got me started, got me interested in microwaves, because I was operating 2 metres and 70 centimetres from home and working across into New Zealand every summer when we get tropospheric openings. What we actually found is that we were constantly being asked, do you have higher bands? Because there was operators in New Zealand looking for contacts in Australia, moving us up in frequency. So for me, this was my introduction, and my first move to go on to 23 centimetres or 1296 was to work New Zealand. And we do that every single year on tropospheric. What happens is we actually get, and typically we get a blocking high sitting in the Pacific, or the Tasman Ocean, that actually creates the conditions for us. I think on the next slide, no, I didn't put it in. I was going to put in one which actually shows you the way the duct forms, but effectively we actually get a colder layer of air typically sitting on the surface of the sea, a warmer band of air, and then another cold one which forms the duct that actually extends. And you can see on this map, which is from the Hepburn charts, and we can use this to actually predict when the actual tropospheric openings are going to occur, usually within, I'd say, close to 90% accuracy. Once we actually start to see these coming through, that we will get a tropospheric opening, and we'll see the predictions that come from Hepburn actually indicating that. We will usually, the time they say it peaks, we will have that duct form, and we'll be able to complete contacts. With a tropospheric, and this is the other exciting part, is it can get out to 4,000 kilometres, up to about 3 or 4 gigs. So again, it's not that 5 or 10 Ks. When we're playing with this and we get the right conditions, it's actually unbelievably fun when you get that signal right out to that distance. The Europeans are doing it fairly recently with their summer between the Canary Islands, EA8, back into both Ireland, right around to, I think it went as far as Greece, where they're actually getting 1296 and 2.4 gig contacts down into the Canary Islands, and I think from memory that's about 3,000 Ks, close to 3,000 Ks. So again, just to prove the fact that it's not always going to be that pure line of sight, you have the opportunity to expand and push those boundaries. The next one, which is actually, once I got onto 2.4 gigs, I actually didn't understand or realise that actually rain actually had a significant impact. More importantly, it actually gave us the opportunity to extend paths. What we actually see is that, and the visual shows it, that's actually from a commercial site, talking about the impacts to commercial microwave and satellite links, that the rain can actually have a significant impact if it sits in the middle. One of the nice parts is that we can actually, if, nope, I didn't put it in, I was going to. During the summer months, we get the very intense storms that usually form down towards Boona, Bow Desert Way. Andrew, VK4CZ, who's based in Warwick, up on the tablelands, completely behind the dividing range. Absolutely impossible to work Andrew any other time of the year, but every time we get a rain scatter, I'll pretend The storm's here, Andrew is sitting at Warwick. We fire beam at the storm and we'll be able to receive him back. And we're getting out to about 200 kilometres line of sight, but the true path is something like 400 or 500 k's by the time we hit the storm and then bounce back. And there is actually a video later where you'll see the sheer amount of distortion that the signal gets in the Doppler from the raindrops, to the point where it's totally unintelligible. I can't remember if I've included that. We'll switch to FM and the wideband modes completely clear, but on SSB absolutely undiscernible and unaudible, yet it can be 40 over the signal strength, which is actually fantastic for this part of the world because we get really intense storms in summer and it's absolutely proving to be successful. Graham VK4CZ, who's down at Grafton's, currently setting up on 2.4 and 3.4 with the view that we'll work over the border ranges with the storms that will set up along the ranges. We're going to try that this summer, so he's setting up at the moment to do that. But as I said, you know, whilst the rain has to be up at that sort of 2 k's above the ground, we're pushing out several hundred kilometres purely scattering the signals out of that intense rain. Anyway, another one which actually probably close to 30 years was really the focus of a lot of the activity in southeast Queensland and also Sydney on 2 metres and to a lesser extent on 70 centimetres was aircraft scatter. During COVID, we've had a slight impact. Planes aren't flying as often, but we still do get to have a little bit of a play with the aircraft scatter between here and there's a couple of stations on the central coast of New South Wales who still operate. And we're completing that path between Brisbane and Kempsey and Brisbane and Port Macquarie on 1296. Purely when we get a plane, and I run this software at home nowadays, is we'll see a plane on the path, it will get within the hotspot. For about 30 seconds to a minute, we will have an elevation in the signal levels, not always real strong, but completely workable to have complete a QSO out to maybe 500 kilometres on both 1296 and 2.4 gig. Purely a piece of metal in the air, bouncing a signal off it when it's in that right spot. 2 metres and 70 centimetres, you can have a full QSO on those frequencies when the plane's in. But unfortunately, at the microwave frequencies, really narrow window, but we really see a significant elevation in the quality of the signal that you actually get.
It does work above 2.4. Current record we've got is on 10 gigs from the border ranges up to Emerald off the back of one aircraft on 10 gigs. We did that a couple of years ago just to prove that it could be done. Sorry.
No, you're right. Jump in whenever you want. Last one. I haven't done this on microwaves yet, but certainly intend to. Kevin's set up on 10 gigs as well as 1296. Yep, for EME. This is, for me, on 6 metres and 2 metres, a hell of a lot of fun is working somebody on the other side of the world, both bouncing the signal off the moon. It's available at microwave. It's actually the signal levels you get on microwaves if you've got enough power are astronomical. The Europeans will have an SSB contact on 1296 and 2.4 gigs off the moon, running a few hundred watts at a big dish, but they can actually have a full SSB contact. Capabilities that probably we're talking about is all digital and maybe CW, but it is possible. But I think the nice part of this one is, again, whilst the stations may only be 15,000 kilometres away, the path the actual signal is taken, depending on where the moon is at the time, could be 400,000 kilometres by the time it's gone up and come back, depending on whether it's at apogee or perigee. But again, another one of the modes that's available to us on microwaves. Before I jump into getting started, any questions at this stage? Please jump in. Okay, just to give a sense of it, what it takes to get on the bands, I thought we'd look at the more common, which are the lower microwave bands, and just actually how simple it is to get on these bands. 23 centimetres, and Ralph and I were talking earlier, a lot of commercial equipment. So what you'll probably find that the easiest way to get on these bands is the commercial equipment. ICOM, Kenwood, probably the two main manufacturers who actually manufacture transceivers with 1296 on board. The old 9700s are still around, occasionally see them second-hand. IC 910s, see them very regularly now second-hand, because people are upgrading to the 9700, to the SDR version. And the TS2000 from Kenwood, which would be 20 years old now, close to it. They have them, and you still see them in the second-hand market. And quite a good radio. We use one up at the VK4IF VHF-UHF field day contest site up at Mount Moglen every year for 23 cents. And it works beautifully for us. From an antenna perspective, it's actually simple. It's Yagis or grid packs, both fairly achievable. This antenna here is a style of grid pack, 1296. The style there is usually the style you'd be using, or typically Yagi. This one here is for 2.4 gigs, but a DL6WU style Yagi is probably what most people use. Commercially available, both the antennas and the transceivers, so it's the entry point most people find to get onto microwave. All commercially available. Stepping up to 2.4 gigs is when you start to have to consider the approach. I think the IC9700 was probably the last of the transceivers to actually commercially come out with 2.4 capability if you paid the extra for that transverter to be built into it. But this is where you start to use an IF radio, and we'll talk a little bit more around it, plus a transverter and a simple antenna. So from 2.4, the 817, 705, a transverter, and we'll talk to those in a bit. Commercially available, the actual transverters, don't have to be constructed. And the small grid pack antennas is probably the simplest way. Once you get down to 3.4 or 3398, which is where we mainly operate, is when you start actually getting more into the construction. But there is still commercially available transverters, and we'll show a couple of those. Actually, there's one on the back of that grid pack there, the little silver box. There's an SG Labs from Bulgaria, a little transverter, $300-400, I think, for the transverter. And 2 watts or 3 watts?
3 watts.
3 watts.
Yeah.
So again, relatively simple, very simple setup. IF, little transverter into a grid pack, operational on 3.4 gig. Once you get to 5 and above is when you start having to either construct or modify equipment typically to actually get activated. But to get started, 23 cents, 9 centimetres, currently all commercially available. And SG Labs are currently working on a little transverter for 5.7, and that'll be my entry back into 5.7 when that comes out. Just a sensational little piece of equipment. Just to give a little bit of a sense about how the transverter works, and there's a great example, which is one of my 2.4 gig transverters here, which is actually built completely on this principle. In that what we have is the transverter sitting in the middle, but it's not the core of the actual system. It's the combination of all the components that actually make it work. So from the perspective and local oscillating, typically the PLL driving the frequency in from the IF radio, they're being combined in the transverter. And I've given some examples down the bottom of how that actually works, and the simplest way to look at it. Let's look at it from the SG Labs 23 centimetre transverter. You have an IF of 144 megahertz being fed into the transverter. The local oscillator sitting at 1152. Really quick piece of math, add the two together, and you're on 1296. Same principle applies as you go up in frequency. Slight difference is when you get up into some of the higher frequencies. I use 24 gigs as an example. Is they're actually using a multiplier typically on the oscillator then to double that local oscillator frequency to give you the combination of the 144, 11952 times 2, giving you the 24 gigahertz output. As I said, later on, come up, have a look. The 2.4 gig transverter is actually each of the modules represents each of those components, and you actually can see it sitting inside the box and how it actually all works. From the perspective of IF, as I said, it's actually, and this has probably got even easier in the last few years, the availability of suitable IF radios. What we are looking for typically with most of the transverters is the capability to have 2 metre or 70 centimetre with multi-mode capability. A few years ago, and that's probably the last of the FT290s that existed, I think I've had the two models before that, plus that one over the years, was probably the first and probably the more common, although the IC202, the old, if anyone knows, the old Icon, almost like a handheld SSB transceiver, they were probably used prior to that as well. But they were really common up until probably 15 years ago, until the 817 came out. 817s dominated the microwave field as far as being the core IF radio. They also, particularly in the Australian market, had the opportunity to actually also, I didn't touch it on the last screen, is actually what we call lock, or put a very stable reference frequency in it, so we knew exactly what the frequency was that we were actually transmitting on. The 817s and VK4CZ, David came out with a little reference board that you could insert in the actual radio, have a precise 10 megahertz frequency inputted, so you knew that that radio was rock stable and exactly on frequency. Same on the transverter, meant that when you turned it on, you knew the frequency you were on. In the old days, we'd sit there and tune up and down until you found each other. Nowadays, we turn on and we're rock solid. We're on the frequency we expect to be on. And lately, and Kevin's brought his little 705 down, this has been, I think, a game changer. I have one. I'm definitely going to get a second one for microwaving. The quality of the actual signal, the audio that the 705 is delivering with the SDR, combined with the transverter, I'm convinced, it may be imagination, but I'm convinced we're hearing a lot more than we were with the 817s or even before. So it's pushing it for us who want to push those boundaries a little bit further, giving us the opportunity. The other part is they're so easy to run on digital. It's purely plug and play, straight into the USB port on the side of the radio, straight into the laptop. Your preferred digital software, you're up and running. So it's really changed the field for us. Most of these 2.5, 5 watts is common, and when we get on the 705, when they're on 2 metres or 70 centimetres of IF, maximum out at about 5 watts is the drive. The antennas, just to quickly look at basics, again, the starting point, probably all know about Yagis. 1296 most common, 2.4, I brought Yagi down, which I built when I first got on 2.4, but grid packs are probably the main antenna there. Probably a range of others that are capable, but the most common on that band, 23 or 2.4 Yagis. Stepping up to the grid pack, again, they're actually available in Australia at the moment. Hard to get the 2.4 gig versions, but there's a guy in both South Australia and VK3 at the moment, making them for $12.96 and $33.98. Not quite as cheap as you probably like, but they're available off the shelf. And also up to 5.4, and they're starting to become more common as the Wi-Fi links that we're seeing for commercial are moving up to 5.4 or 5.5, I think it is, for Wi-Fi. They're using modified versions of the grid pack, so they're becoming cheaper and more easily accessible. Once you start getting above 3.4, but even at 3.4 is when we start looking at dishes. From that frequency up, typically the dish will be the antenna you'll be using. Might do the whole range of other smaller ones, horns, reflectors, but what you'll see most commonly will be dishes at those high frequencies. As I said earlier, it's getting easier to get on microwave. We're actually fortunate in Australia. Mark of VK5 EME runs a company called Minikits. Mark actually now sells transverter kits for 1.2, 2.4 and I think 3.4 gigs. Also a hell of a lot of parts. I won't tell my wife, but another couple $100 worth of parts arrived during the week in a box. The lovely eBay, huge amount of equipment and parts can be obtained through eBay, both the commercial suppliers but also people parting out other commercial equipment. Internationally, what we're seeing, Down East Microwave in the States was huge in the 80s and 90s. They're not quite as big at the moment. They still do have a small range, but they used to have transverters from 2 metres right through to, I think they stopped at 10 gigs, maybe gone to 24. They've compressed their range, but they're still operating. There's a Down East Microwave amplifier in the 10 gig system here. Kuhn Electronics, probably the premier builder of microwave transverters in the world at the moment. Although SG Labs is fast catching up from both the quality but also a third of the price typically of what Kuhn would charge. Kuhn is DB6NT. He runs a large commercial manufacturing enterprise for microwaves. The Amidoside's a spin-off for him, but the equipment he produces, Kevin, you've got transverter plus amplifier in that 10 gigahertz system. And W1 GHZ with a call sign like that, you're probably going to be operating microwaves. Great designer of fairly basic transverters, but also you can buy kits and parts through his online store. So again, it's not that hard. It does take a little bit. You can't just walk into JK, you can't walk down to what's Slim's place down in Melbourne? Anyway, Strictly Ham to purchase it, but there are suppliers that are reasonably readily available to most amateurs nowadays. Righto. One of the things I said I'd do is just provide a focus on a few of the bands, give you a little bit more of an in-depth look at each of the bands, and step through, can't remember how far I went, might have gone to 10 gigahertz on this, but to look at it, what is basic, then also what do you start to consider when you start pushing that a little bit to get a little bit more competitive and push those distances. Said earlier, basic on 23 centimetres, typically 10 watt transceiver, small Yagi, small in terms of 23 centimetres. If you're on 2 metres with 25 elements, it's quite a large Yagi, but on 23, 25 elements, still only a couple of metres long. Getting up to being more competitive is when you start introducing amplifiers and you're looking at bigger antennas. 40 elements on 23 centimetres still is not a big antenna. 48 I built to you is only 3.5 metres long. So again, from a suburban perspective, you actually can run a very competitive station without the huge antenna systems that you have on the lower bands. Band plane in Australia, 1.24 gigs to 1300. Where we sit, 1296. Little narrow band segment up here is where we predominantly are. Usually for us on 1296.1 plus or minus, and digital up around 1296.2 to 0.3. But a really narrow band, but a hell of a lot of bandwidth to play. And as I said earlier, this is where we're still seeing a lot of ATV activity, and the Brisbane, I think the Brisbane Digital TV Club still run a repeater on 1296. Give you a sense of the distances that are achievable on 23 centimetres. Currently out of the WAA records, the national records is Young Hayden, VK7HH to ZL1IU, just under 2,500 kilometres. That was Tropo last summer. From a VK4 perspective, Rex VK4REX up on the Sunshine Coast across the ZL1SWW at 2,356. And digital is a VK2. We'd easily beat it. I think we've worked ZL on digital many times, so we'd be sitting up at 2,200 Ks from just north of Brisbane where we are. Probably need to submit those.
I think we should.
Knock Ross off his little pedestal. If Ross is watching, apologies. 2.4, that's Stu, VK4SLA, operating my 2.4 gigs from Gus Boutel Lookout. I think we're getting Stu interested. He certainly professionally actually works with microwaves and never been exposed to them from an amateur perspective, and we've done that and starting to ask lots of questions, and most mad days when he's available, he'll be out with me nowadays. But on a 2.4 perspective, touched on the basics earlier, IF, small transverter, grid pack, pushing up here, we are starting to look at amplifiers, 20 watt minimum being what we probably look at start being competitive. I have a 200 watt amplifier on my work bench at the moment for 2.4, which if we're in lockdown the next couple of days, I might actually get into the workshop for a change and actually progress that a little bit. It's been on the bench for probably a good 12 or 18 months. Unfortunately, I don't get as much time down there as I'd like, and we're starting to look at the bigger grid packs. This grid pack here originally was one of the little 18 dBi grid packs. This one's been modified to 3.4. The one here in the corner is a 24 dBi grid pack at 2.4. There is a video here later of my signal on 2.4 being recorded in ZL with 20 watts on one of those grid packs from home. About 2,200 kilometres, and you'll see that in a little bit. Records on this one, Young Hayden and Richie, VK7ZBX, 2,300. From Queensland here, it's about 2,100, 2,200, depending on the two stations who are typically active in ZL. The VK4 record is Adrian, VK4RX up at Mullaney. This year when we're up at Mount Mablin, we'll try and bounce that one and push Adrian off the lip. And Kevin, you're responsible for that one?
That was me too, long time ago.
VK9 is the digital record. Again, We should be able to easily beat that with the stations we have up here now on 2.4 from Queensland.
Can I ask you something?
Yeah.
The records, are they usually made on SSB, or is it just a CW signal, or what?
About to say, you'll see the video later, but what we're doing nowadays, we're starting digital. Those of us who are CW active move to CW, then to SSB. But they're not weak signals. They'll start off weak, but they're not weak. And you'll see that when we play the video. 3398, well, that transverter's sitting here. It's sitting out next to my driveway gun. But again, basic station, little IF transceiver, FT817, couple of watts out of a SG Lab type transverter into a grid pack. Starting to get up into larger systems where probably predominantly what we're using with the microwave activity days when we're in the field. Looking at probably minimum of 20 watts. I think most of us are around 30 to 50 watts nowadays on 3.4 gigs. Large grid packs, what were the 24 gigahertz grid pads for 2.4 gigs, modifying to 3.4, giving, I think we've estimated around 30 dB gain. So really effective gain from the antenna. Again, fairly narrow band. We're sitting here, narrow band for us on SSB and CW, a little slither in here. We're restricted, but we're sitting at 3398, so right just below 3400 where the restrictions come in. Records on this one, and you'll actually see the video of this contact being made was Kevin, and then beat me by a whole minute because Kevin was using his equipment. Then I grabbed the microphone after Kevin to have the second contact. That's from Mount Moblin, actually at the peak of Mount Moblin, up in the Bunya Mountains to Steve ZL1 TPH on 3.4 at 2,193 kilometres. Again, started weak, but I think we peaked at S9. From a VK4 perspective, we still hold the national record up here, as well as the VK4 record, and digital is 502 Ks. Again, we should be able to break that this year. I've now, we'll see it later, I've now got 3.4 gig home station with the view of breaking that. I did say I was competitive earlier, didn't I? Righto, I'll jump up to 10 gigs. And what we'll see, again, come down and ask questions about Kevin's big system here. That's next level below this one. Basic, typically half a watt, feeding a small 400mm dish is probably what most people start with on 10 gigs. Most of us out in the field, microwave activity days are running somewhere between 3 and 10 watts, and usually into about a 600mm dish. And I think roughly the calculation of 3 watts into 600mm is about 800 watts EIRP or a bit higher. So it's a really effective little system that's this big. Again, from a record perspective, the national record on this is Rex VK7OMO from the northern part of Tasmania, right across to the bottom of Western Australia. Again, a tropo opening. He'd been watching the maps, planning it, and planning with VK6DZ. I think they did over a series of a couple of days until they finally made the contact. Kevin talked earlier about the VK4 record, which was from Cameron Lookout,
Yep.
up to central Queensland, 573 kilometres on 10 gigahertz. Commercially, 10 gigs would be what, 15, 20 kilometre?
Yeah.
And again, we don't care if it's not reliable, as long as we make the contact, so we're pushing that to that 500 odd kilometres. And the digital record is actually the national. They completed it using a digital mode. Righto, where you'll find activity in southeast Queensland. Not so subtle plug for the Brisbane VHF group. They have a sensational beacon system sitting at Eden's Landing, southeastern part of Brisbane. Beacons are running on 23 centimetres through to 24 gigs, 24/7, unless Rob turns it off accidentally.
And 2 and 70.
Oh, and 2 and 70. No, 70. 2's RBB.
70 centimetres from there.
Sorry.
Are they running 24 hours?
24 hours, 24/7.
They're
That's a-
digitally encoded, frequency locked, and they're 24 hours.
As Kevin
What
said,
kind of signal do they put out? Is it Morse code or?
Morse and digital.
Okay.
So both. So
What digital?
typically JT4F, which is one of probably the more common digital modes on microwave.
How high is the location then?
It's actually a pretty high spot. It's like a little.
It's not astronomically high
Right,
from
but it's very
like
clear.
a mountain top, but it's...
Can
think
we
it's-
hear it?
yeah,
You should.
can hear it.
We were going to do it, but probably ran out of time. You'd probably hear it down to 3.4 from.
From Mount Mobilon, which is several hundred kilometres, we've heard right up, including the 10 gig one,
Yeah.
a good strength.
So you better go on with this.
No. But that's available. So if you've got any system that's capable of those frequencies, that's there. Again, perfect for when you're playing and tuning up. Once you move off the sig gens in the workshop, to actually then get a live signal. Where the activity actually, when you start to see some of us on air, probably two main drivers in Queensland outside of the field days, and we'll touch on field days. 23 on 23 is a concept that Adam, VK4GH and I came up with probably about 10 years ago to try and drive some activity on 23 centimetres. Easy to remember, the 23rd of every month at 8 p.m, there'll be stations on 23 centimetres on 1296.1 in southeast Queensland. I think our record was 30 stations one night. Most 23 on 23, we usually typically get about 10 or 12 stations. The old days of VK Logger, not VK Spotter, we used to be able to search and research all the stations who put their details in, their equipment. Brisbane used to have 35 stations on 23 centimetres who were active. So our best was not quite that many, but we almost got the Brisbane population of 23 centimetre drops up. As I said, typically nowadays about 10 to 12 come up on 23 and 23. The next one, which Mark, Ralph and Jamie, who's not here, have experienced in the microwave activity days. You'll see a couple of their mugshots in a second, sitting on top of hilltops. They are not as frequent. We actually try to coordinate those on convenient weekends when people are available and fitting in between field days, contests, other things. So they're prescribed. We set a calendar for 12 months. But anyone's actually available to operate on those and welcome to operate, but it's from 23 centimetres up. I think we're currently stopping about 47 gigs most of the MAD activity weekends, so there's people out there operating from 23 up to 47 depending on the equipment and capability they have. And the other side was the reason we started doing this was forcing us to get out more often and being portable. It's really hard to work microwaves from home. A lot of people don't live in the right locations. This gave us the opportunity to try and drive the activity and drive some more interest around Brisbane. Last two, VHF field days 3 times annually. Spring, summer and winter. And I'm not going to tell you the dates because every year they're slightly different, but they're all published on the WAA website. And next one for us is spring, 27th, 28th of November this year. We'll be actually operating again from the contest site on the top of Mount Mobilon for 24 hours. We'll have 6 metres right through to 24 gigs up there this year. We actually won it not last spring, the spring before. First time anyone outside of VK3 has won the field day. So again, we're not competitive. And lastly, one which we're now Kevin's back in president of the VHF group. We'll try and push to get a few more of these up and running. This is one of the things that really was a catalyst to, again, me moving from 23 and up, was the opportunity to actually get into what was the test and tune days, where people were bringing the equipment where you could actually test your equipment and actually ensure it was working. My 2.4 gig system there, I'd had one contact, really poor contact, was disheartened. Took to the test day, somebody found one little mistake I made, fixed it, and it's been great ever since. But the opportunity to get there, talk to members of the Brisbane VHF group, also Redcliffe Radio Club, the last one was at Redcliffe, but the chance to bring the gear in, put it on really good, high quality test gear and actually test it and make sure it's operating properly. So they're probably the 4 main sources of activity around southeast Queensland at the moment. And this is where we start to look at some of the activity, give you a sense of actually what some of the contacts are like. This one's 23 centimetres. I've lost the sound.
Charlie Zulu, Zulu Lima 1 Tango.
The speaker's turned off.
Papa Hotel 1296 100. QSL there, Scott, VK4 Charlie Zulu ZL1 TPH, Portable Myers Hill, north of Auckland. Yeah, likewise, you're also a 57, okay?
At the same time. So that's 1296, about 2,150 kilometres. And as you saw, well, that's Stephen there, but I was up to S9. That's from my home station, 180 watts to, at that stage, a 36 element Yagi. I've now got a 74 element single, 74 element Yagi at home. You'll see that.
VK4 Charlie Zulu.
Polarisation, predominantly horizontal. I was based up at Gaspertel Lookout. Doug VK4ADC was running just under a watt. And I think I had it up there before, about 87 Ks, and is well over S9.
I'm really pleased with the way it's working. Okay, someone calling you on 2 metres, VK4CZ, portable, VK4ADC, music.
Put this one on here because it's actually really interesting. You can see behind, I'm actually beaming through the rainforest. It shouldn't have worked. But Robert 4LHD, he's now CG. Alright, this one's the rain scatter. You can see the signal meter, but have a listen to the audio. Once it loads. But that's the Doppler. I didn't include it in here, but we immediately shifted to FM, full quietening S9 plus signal, 100 odd kilometres. This one, the 3398, this is, I won't play the whole lot, it goes for 6 minutes, but Kevin's contacted ZL at 2,193 Ks.
Well, I've just looked at the tropo charts. We've got a good chance of making some good contacts today, Steve. What's the weather like with you? Is that a 1 TPH?
Kevin was liaising on 2 metres across to New Zealand. So he's probably up around S7, S8 on 2 metres. That's Stephen on 3.4 gigs.
QSL 52, Steve, you're 5 by 5, 55, 55 QSL. Mate, we've just broken the Australian record. Let's come back up again, and we're going to try and record some of this for posterity. ZL1 TPH,
Didn't notice I was filming anyway.
Yeah, Roger, ZL1 TPH, VK4 Uniform Hotel Portable, VK4UH Portable, VK4UH Portable, copy. VK4 Uniform Hotel Portable, VK4UH Portable, QSL.
What we were finding that day was really deep QSB. And that was one of the big
QSL
fades, but still
5x2.
workable.
You are 5x4, 54 speed, go ahead. Steve, I'll give you an ident.
I'll jump ahead, but you heard Steve at the start of that. You know, he's up to 5 and 7 at the start of that contactor.
I'll give you some.
Righto, just to give you a sense, a few pics here just to show some of the setup, some of the operations. This is VK4IF, the contest station. We run typically spring and summer field days from a location at the just below the trig point. Would probably only be 100 metres from the trig point on Mount Moblin. We operate up there from 6 metres right through to 24 gigs. That's the two ends of the path on the 3.4 gig contact and the Australian record. The system we were using here in Queensland, and Stephen, the grid, his transverter just mounted off the bumper bar, or the rear tow bar of his car, but sitting at a very high location up at, he was at Cape Reinga that time, wasn't he? Yeah. So right at the very tip of the North Island. I wanted to put this one in here, it gives you a sense of how simple it can be, and I brought one of these little panels down to get, and if we get a chance we'll actually fire it up, have a couple of contacts. Peter, VK4EA, went out to Moreton Island camping. He took 2.4 and 3.4 gigs out, panel antenna, SG lab transverter, and we were each morning and afternoon having contacts just out to Moreton Island. So it's not far, it's, I think it's about 40-50 k's from home, almost line of sight, but S9 type signals. Although, middle of the day, we were struggling to make the contacts. So we were having an impact on the path during the day. But again, it shows how simple you can and can start, and the distance you can get with a really simple setup. Just for fun, I actually worked you when you were out in the boat. This is Kevin operating 10 gigs from the middle of Moreton Bay. So don't have to always be on top of a mountain, just need to be in a nice clear location. I was actually at Cameron Lookout that day, and then I worked you, from memory, I worked you again from Duck Creek Road, which is the four-wheel drive track that goes down the back side of, from O'Reilly's down into the back of Canundra, and I can't remember the name, I think it's Kylie, or the rural area down there. This was Microwave Activity Day. Jamie, he came up probably a bit over 12 months ago for his first experience operating 3.4 gigs. Another couple of dodgy characters. Mark and Ralph came up to Cameron Lookout.
Yeah, dodgy.
This was March, probably March. Again, Mark's on, that's my 10 gig system, and at the back of the vehicle I think he was operating 23 SEMS. That shouldn't happen. That was a lone system, wasn't it, Kevin?
Yeah.
Yeah, 10 gigs, high power 10 gig system operating up at Toowoomba. And from that one, you're trying to break records going west.
Yeah.
Yep.
Worked across to
St George.
St George, that's right, which it's a fair path.
About
Happy with that on 2 meters, let alone 10 gigs.
250, 300 Ks, I think, from memory. Be out there next week. This is Gus Boutel Lookout. You saw the picture earlier. Stu, VK4SLA, and myself. Only got 2.4 and 3.4 gigs set up there. Peter, VK4EA. Peter and myself down here. That's north of Toowoomba, and that was last VHF field day. Peter came up to try 24 gigs to work us up at Mount Moblin. And that is on top of a hill. There's actually a trig point there up at Blackbutt. The best location you can find in the area. Path profiles are perfect. We couldn't work a single station. It is just an RF hole. We can't explain why, but we've done it twice. We thought it could be atmospheric, could be conditions, no. We can't explain it. The path profiles say we should be having great contacts. We just can't work anyway. So do not understand it. Just to prove it's not always older people, and I think we joke down at Gibbs Tech, the vast majority have beards. That's my son Campbell, 4YR, pre-long hair and post-long hair, operating 10 gigs and 3.4 gigs. I think the only time he ever gets on the air is on microwaves. Cole, VK4UV, or as he was I think back then, VK4MIL. That's a Gus Patel lookout, and from memory it was either 3.4 or 5.4. And they're not always beautiful sunny days. And lastly, just a quick version of my home station. The 3.4 30 watt transverter, the 2.4, which is the one here, but that will be replaced. The rack system at home's got space for the 200 watt 2.4 transverter to go in there. Antennas, 12 element loop fed array for 2 meters. I've now got probably better on the nighttime shot. That was during the recent eclipse. A single grid pack, one of these large grid packs on 3.4 gigs. I've now got stacked grid packs on 2.4. Sitting above that, 30 elements on 70 centimetres. And above that, 74 elements now on 23 centimetres. That's the shortest antenna at 6.5 metres. That's just under 8 metres and 7.2 metres for the 23 centimetres. My original plan was to build 4 and stack 4 of them. That thing, I move 5 degrees off a station, I lose them. So I've given up on stacking the 4. I think I've used all the material up building antennas for others, but yeah, the original plan was 4 74s. That's it. Any questions?
How do you, I imagine on the higher frequencies of the big dish that the beam angle would be very tightly focused. So how do you initially aim them? Do you have a map or something and you use a compass?
Yeah.
I might cover some of that because I've had to address that very issue.
Okay.
And using parabolic dishes is probably one of the, from my point of view, is one of the most fulfilling things because they are so sharp. It's hard to, if you come from HF as I did, to understand just how much gain you can get from an antenna system where you, if you're pointing, you've got to have the reflexes of a F111 pilot. The perfect aiming point is between there and there, between having a signal or not. I brought down 2 systems for you to have a look at the 2 extremes. This one we'll start with. This is a 3.4 gig system, a 6 centimeter system. It's a grid pack, and these, although they're quite expensive to buy now if you buy with the internet, we picked up a stack of these off the pavement for nothing. They were designed beautifully to be used outside and for 2.4 for Wi-Fi use. We've actually worked out a way of converting them to other bands because the dish doesn't know anything about frequency. It's only the feed. It's only a dipole inside here which illuminates that dish. So this is a very, very simple 3.4 gig system. It has one of those SG Lab transverters, the ones that come from Bulgaria that Scott talked about. They're a couple $100, and that's it. That's all you need. The antenna's bolted straight to this. You give it 12 volts. You give it an IF radio. It does everything else. It does transmit, receive. It's RF sensing, so you don't even need a PTT line. You just whistle, and as soon as it sees RF, it starts transmitting. And if you configure it internally, you can actually feed the 12 volts up the feeder as well. So that's a home station. And this dish here gives you about 30 dB of gain. Now, to get some perspective on that, that means if you have 1 watt of RF, you've got 1 kilowatt of ERP. But the cost of that ERP is a very narrow beam width. These are actually not too bad. I'll just show you that I've got an oscillator running in the car outside, just to give you an idea. It's very close range and there's reflections of everything. But if you turn the dish away, you can hear I can see the S meter going from 20/9 down to S5. Hear the Doppler effect of things reflecting. So that's that's the really cheap and easy way to get on microwaves these days. You buy a cheap little transverter and you interface it with your SSB or FM or CW, whatever mode you got in your IF radio, you've got on air. That does digital as well, so it'll just do everything. Coming over to the other extreme, to this one, well, the beauty of not having any training in engineering, mechanics or electronics is that you can do whatever you like because there are no wrong answers. You just find out how to do it. This is a system that I've put together. Now this is capable of doing EME on 10 gigs. It's a 600mm dish. It's based on Kuhn modules. You can all come and have a look at this. But this one's got a 60-watt amplifier in it, which is an unbelievable amount of power on that band. Now, the gain of a dish goes up and up and up as the frequency goes up and the wavelength gets shorter. It's the number of wavelengths across it is rather than the diameter. So on 10 gigs, this little 600mm 2-foot dish has got close on 36 dB of gain. And that means if you take that story forward, you put 1 watt of power into that, you get 6 kilowatts of ERP, and if you put 60 watts into it, you've got something just short of 1/4 of a megawatt of effective radiated power. And that's what this will do. And a system like this is easily capable of EME and working into the States, working into Japan, working into New Zealand, anywhere. But of course the cost is that you have to be able to point it, which is the reason that you asked. And so I built this frame. This was built by me. It has a rotary mill table in the bottom, which will turn the whole system round. And I cut a scale on the bottom, which is will give me an azimuth accuracy of within 1 degree. So I can get this pointed accurately and elevation the same, because the moon's going up and down in the sky as well, of course. And to get it calibrated, I use a rifle sight which looks through the dish, a tiny hole in the dish, and you can either get a look on a map, find a mast or some easily recognizable feature on the horizon, within a 20k of you or so, and look on Google Earth and say, okay, that's at the actual heading from that to me is on 216, set this to 216, and then you can wind and you can pick up any angle you want. The moon moving quite fast. If you want to do EME, the software programs will actually tell you where the moon and the sun are. So if you've got a visual sighting, you can use the rifle sight to focus. Or if you haven't got sight of the moon, then you can aim on the sun. Now, I might say it's not all that smart to be looking at the sun through a telescope, but it's not that hard. This has got a little filter across the front of it which I made out of a welding mask. So you can take a sighting off the sun if that's what you want and calibrate up. So when you go into the higher microwave bands, you can sometimes, the coaxial cable as a feeder, the gain and the loss start to become pretty high. So the optimum way to do it when you can is to switch across into waveguide. And this is an entirely waveguide based system. That's all coax. This is waveguide. That means your aerial changeover must be in waveguide as well. And you'll see all that in here. So this is the top end. This is about as much as you can achieve amateur-wise to something that's the simplest of all. So as I say, this has got an ERP of something approaching 1/4 of a megawatt. It also makes a very loud noise for terrestrial work as well. So I sort of copied somebody else's designs, purely plagiarized. I saw somebody else doing it, I can do that. And that's how this system was built. So by all means come up and have a look, have a play with the mechanics, see what you think. The only other bit of the system that I haven't shown you is when you go out microwave, you take your microwave go box, something that's convenient. What you don't want to do is drive 300 kilometers and find you've forgotten that one lead that you need to make this all work. So this little box has got an FT817 in it. It has a battery in it, so it can run by itself. It has a GPS in it, so that I can generate the 10 megs for locking. It has a digital interface. It has what we call the U-guide. It goes dit, 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 dit. It's connected to the CW keyer, so when you want to set your contacts up, you just set the thing to give a whole string of dits, so the guy at the other end can wind his dish right. He does the same. You get your bits right, and then you can pick up the mic and work. Got a speaker in, because the 817's a bit weak on the speaker. GPS antenna in the lid. or go. So as long as you've got that box with you, switch it on, she's ready to go. And the umbilical cable, I built all my transverters so they had all the same connectors on. So it doesn't matter, I can switch from 10 gigs, just plug it in. There's a 2.4 gigs on it, plug this in, they all work together. They're all exactly the same. So that when you're at Portwood, you don't have to wonder, what did I do with a little bit of cable that's that long with the red plug and the blue plug. So by all means, come and have a look at all these things, see what you think.
Can I ask you a question?
Of course you can.
You'll probably run into this before. The old Ostar satellite TV system there, what frequency did they use up and down from their satellite?
I don't know the answer to that.
2.3?
2.3.
Can you use that gear?
Yes, well you can certainly use the dishes.
I've used the Galaxy ones on 2.4
Yeah.
Wi-Fi. I just put a USB stick in there and use the USB cable up the middle of it and just fine tune it, and it works really well. Just as they are, just pull the whole guts of the middle out of it and just stick a USB cable up in it, USB thing, and fine tune it. And it works
A lot of the satellite TV receivers, of course all the clever stuff is in the little block that's up on the dish. And I know some of the VK3s that get hold of these, they've got a box full of them that have been thrown out, so they just run the mill over the top of them, cut all the lid off, have a look, oh yes, we can either pinch the devices out of that, or we'll just snowflake them, we'll just alter the resonance frequencies a few tracks, and they'll work certainly on receive. And a lot of people still do that. Microwaves, yes, you do have to do a little bit of home construction somewhere, because you can't buy this stuff off the shelf. You're going to have to put a bit of input in, even if it's only for the antennas, but we do that on HF as well. And you can go up for this sort of system. That's crazy, it was madness, but it's something I wanted to do. These are easy, and that's the entry level.
The next question, you as a medical doctor, what precautions are you making when you are putting 250,000 watts out of that?
Can I tell you the truth?
Yeah.
I think that's all bullshit. There is no risk from microwaves. I mean, like any RF, the only danger from microwaves, the only scientific biological data is that it causes heating. That's the only effect of RF, is that it causes heating. There's an awful lot of stuff that's spoken about what are the safe exposure limits, etc., etc. I don't look down straight eyeball into a waveguide, that's just silly. But from there on, this stuff is not toxic. It doesn't cause cancer, it doesn't cause leukemia, it doesn't make your eyeballs fall out, it doesn't give you cataracts, that's all nonsense. Okay? As long as your exposure is less than out in the sunshine, you go out in the sunshine here in Queensland, 2 kilowatts per square metre of incident light, including wavelengths which are damaging to health and can cause cancer. The limit officially is 2 watts per square metre, which is actually, you don't exceed this. Although you've got an ERP of 250 kilowatts, that's not real power. You can't go in there and find 250 kilowatts, it's not there. It's only because it's being concentrated into a small area, but it's still only 60 watts or 3 watts. So I don't have any health concerns. If I did, I wouldn't do it. I think it's overstated. Not everybody agrees with that, and there are limits, and you have to stay within them, same as you do with your HF station at home. We're all limited to exposure limits, but in reality, it's safe. It's non-ionizing radiation. Once you start to get to wavelengths above ultraviolet, then you start to knock electrons out of DNA, and that's the cause of cancer and tumours and cataracts and all the rest of it. This stuff doesn't do that. Yes?
I play with digital TV and use software-defined radios both as modulators and for improvised test equipment, because it comes pretty, you've got to have the test gear when you're playing with digital TV for filters and all that sort of stuff. I was just wondering if people are using the SDRs both as sources and for improvised instrumentation.
They are.
You can get up to 6 gig pretty easily.
Yes, they are, and there are solutions. I'm not a big SDR person, but people are using them as the IF radios, both on transmit and receive, and for digital encoding. And as you said, there are now versions which are called the line. line
line
SDRs will
SDR,
actually start to get you RF directly out on many of the microwave frequencies, and I think that's the next obvious place which this is going to go. We're going to start to be able to digitally generate even our SSB signals right up into the microwave bands. It's going to become easier, not more difficult.
The Europeans on 122, this exact transverter system here, are using SDR, just the little dongle ones for the receive component, whereas at the moment I'm using an FT817 because these 122 gigs are an FM only transverter at this stage. The actual FM is generated, the transmit's generated, but you need an IF as a receiver. And in Europe I know they're using SDRs.
Well, you can transmit and receive with something like a Pluto or a line SDR.
Yeah. These don't need it, but yes you can. Yeah. The actual transmitter at 122 gigs is actually all built in, all you do is plug a microphone into it.
So just to get back to that question about safety, and I have to agree that we are bound by legislation and the exposure limits that we're allowed to generate. Where as amateurs we're restricted to those same limits, but from a personal medical perspective it's not backed up by any biological science that there's any risk there. But you do have to apply common sense, as you do with all RF systems. You pick up a 60-watt soldering iron, it will burn you. You put anything living into a microwave oven, it will be damaged. But what we do, it's not real power. It's the clue is in the name. It's effective radiated power. It's not real. Yes.
But with that said, does that affect the wildlife?
No.
With their little inbuilt GPS systems they got.
There's no evidence to show that it has any biological effect other than heating if you get enough energy. Same as going out in the sun. So no, there is no effect on wildlife or on nature. They're all quite safe, as are we. Well, thank you for listening. It's been a pleasure to come down. And by all means, come and have a look. If you've got any questions about any of the stuff, any suggestions about the mechanics, I'd love to hear it, because I always liking to pick off other people's ideas.
Thank you.
Right, thanks guys. So it's the most interesting area of the hobby, and I know these guys have just come for a long trip and obviously going to be home by 4 o'clock. In case you haven't heard, there's a lockdown from 4 o'clock this afternoon. We'll have a barbecue going in a minute, just getting everything going, and obviously while you're waiting, come have a look. I'm sure the guys will answer any questions, and I know I'll have a few suggestions where you get some microwave dishes.
Good, good.
I've already got two, thanks Matt.
All right, thank you. All right,
Thanks
everyone.